I think I will revise few things yesterday what I done. Okay. So what I'm doing now is the fifth model. I think yesterday few people, many people attended. I think I'm happy for that. So yeah, I will quickly revise what I done yesterday, and then I'll move to few more things. The fifth model they have introduced you newly for you people. Fifth model they have introduced newly for you people. Okay, so this is all the tertiary treatment we call. So I will try to quickly go to that. So I told yesterday how nitrogen exists in this environment. So all form of things I told yesterday. So it's in the gaseous and ionic form, it exists in ammonia, and when it oxidizes, it turns to nitrite, and further oxidation, it will convert into nitrate. Okay, so with that, it also converted into gases by as a nitrogen gas through bacteria, and this again the plants and some animals consume that again becomes in an organic nitrogen. Okay, here in plants and here in animal. Okay, so this is what I done yesterday. So now how do you remove this nitrogen? I was talking about that yesterday. So around 4 to 5 steps I explained. So before that, if nitrogen is existing more in lakes, what happens to lakes is this is a condition you see now. Your lakes looks like this, completely covered with plants like this. It's nothing but eutrophication phenomena. I told you in the yesterday class. Okay, so nitrogen in water exists in three forms. This is all the form of nitrogen. This is ammonia we call. It may be gaseous or ionic, and it exists as a nitrite and also nitrate. Okay. So then when measuring this nitrogen, the total nitrogen is completely due to this all three things. It is due to ammonia, due to these two things, nitrite and nitrate, and also some organic nitrogen exists because of the bacteria. They also accumulate all this nitrogen inside the cell. So because of that, organic nitrogen also exists. So, and one more way of measuring total all the nitrogen you have, that is combination of these two things only. You leaving these oxidized states, ammonia and organic nitrogen, combination of this we call as total sedohyl nitrogen. Okay. Then one more form is total inorganic nitrogen. It is due to this oxide states and ammonia. Due to these two things, we call total inorganic nitrogen. Okay, so these are not they will not typical ask, but they will ask is how you will do what is nitrification, what is denitrification. You have to explain with reactions. That is the question they will ask. So this is all ammonia and ionic ammonia exist. So pH is directly linked here. When the pH is reaching 12, you will observe ammonia and ionic ammonia. Okay, in the wastewater. But if it pH is less, then the ionic ammonia it will be in higher form. With respect to ammonia and ionic ammonia, this ammonia ions state will be seen if the pH is acidic, and if it is basic, you will see only gas, ammonia gas, not ionic. Okay, so then what is nitrification then? So this is the last. So your ammonia converted into nitrite and nitrate. So that is called nitrification. How it is done is these two bacteria you see, autotrophs and heterotrophs. This exists in plant, this exists in animals. Okay. So in terms of population, this will exist higher because of the bacteria consumption. These heterotrophs exist higher and autotrophs are lesser. So these are the responsible bacteria which converts this ammonia into nitrates and nitrites. Okay, so there is a two part when explaining nitrification. So you have to explain with reaction like this. First you have ammonia and oxygen will be there. This bacteria will consume that and it will convert into acid, water, and nitrite. So this is one form you have seen. The further of this, what happens? This nitrate, because of the oxygen availability, they convert into nitrate by bacteria. Okay. So this whole conversion is called nitrification, right? Converting ammonia into nitrite and nitrates. Then what is denitrification? It's not like ammonia reversing back to nitrate. Actually, it is not denitrification. Denitrification is something where the nitrate which was there in the last state, bacteria start consuming that and they try to convert it into nitrogen gas. Okay, so that is denitrification. Means atmosphere, this gas will be released like a bubble, but it is nitrogen gas. They will consume this nitrate with food and available oxygen. Okay, so they convert this nitrate into gas, nitrogen gas. So and also energy will be released. So you will be seeing like this bubbles and all in wastewater. So this is denitrification process. Bubbles and all you're seeing now. So yeah, so why to remove this nitrogen? You already know excess of nitrogen causes like this eutrophication. Um, so we have to, sunlight and all will get affected, right? The fishes will die actually if you see green like this. Okay, so that is the purpose why you have to remove nitrogen. Okay, so next topic is there. One more topic is there where you have to remove phosphorus. Nitrogen, I told few more things yesterday: assimilation, nitrification and denitrification. Many steps was there. Yesterday I covered that. I will send you that PDF. And one more way of removing nitrogen is this ammonia stripping. Means passing this ammonia gas. Okay, so this is called ammonia stripping. I will take you there. Wait, ammonia stripping is here. I think. See here. I think what I covered till now. This nitrogen removal. Wait, I will share the screen. I think, yeah, nitrogen removal. So this was I was talking about. You have air stripping method also. One more method exists, air stripping, and this already you know, right? So air stripping also one more method. It's see here how the air stripping how they will do in the figure. Water inlet is coming here. This is distribution system. Air is outlet like this. Fan will be there. Air is entering. Air is going out. Okay, we are providing oxygen. So that is called air stripping. So one more method you have. What is this? It consists of converting ammonia into gaseous phase and then dispersing the liquid in air, thus allowing transfer of ammonia from wastewater to air. Okay, so this is the definition. We are going to convert this ammonia into air. Okay, so this is how it will works. The gaseous phase ammonia and aqueous phase exist together. You know, these two things exist in equilibrium and some abundance exist like pH, temperature, so they keep varying. Okay, so to do this air stripping, the pH must be 11, greater than 11, it should be there to completely convert ammonia. Okay, so up to here you read and try to draw this figure. So one more method you have, and these two things I already explained: biological nitrification, denitrification. This is nitrification process. This reaction you have to write. Okay, this I will send you this. This is exactly what you have to read, and you have to mention this bacterias. Okay, So then denitrification also, I already told you, the nitrate converted into gases, right? This nitrate converted into nitrous oxide, some gases. Okay. So that also you explain up to here, your one concept finishes. So one more you have phosphorus removal. So that I'm doing now. One more topic you have phosphorus removal. Okay. So you know phosphorus also what is a nutrition, but since it is, you know, every day the agriculture activity finding more phosphorus amount they're releasing into lakes and rivers, so it also causing some problem to lakes, so we have to remove that. And also phosphorus exists mainly in soap bubble, you know, manufacture of soap, the leathering will use because of this phosphorus content. So normally in treatment plant we can't remove everything, it only removes 1 to 2 mg per liter of phosphorus. Okay. So so we have to remove that. So there is two methods are there, precipitation methods are there, so that you have to study. Okay. So see here, first thing, specific bacteria, one bacteria exists, okay, heterotropic bacteria. uh, it is sometimes we call it as PAOs, means phosphate accumulating organisms we call, because this phosphate they consume and they will accumulate in their cell. Okay, those bacteria exist, no, they will accumulate in the cell. So that is how phosphorus is removed, one method actually, so biological method what I'm covering now. So one more method you have, physical and chemical, I will do that after this. Okay. So here in this method they're telling, you know, it requires anaerobic or aerobic sequences, and COD and BOD ratio should be greater than 45. Sorry, COD and phosphorus ratio should be greater than 45. So we will see now how they will convert. Okay. So this is a one technique they adapt. They are providing both method here, aerobic and anaerobic. Okay. You know, condition they are providing here. Influent is going, it's completely closed. Some reaction will take place. Again, they will pass here. Here, air is again provided here. After that, it will move to clarifier, means sedimentation tank. So here, the phosphorus is removed and it will settle as a sludge. Okay. So sometime they will pass this sludge to the influent. So that is how they will do. So just remember these two things, the combination of these two things, and these you will write it anyway. Do you know this? One sedimentation tank you have to keep, bottom sludge will come and part of it we will return it so that microbes again grow back. We call return sludge. You have learned it in activated sludge process. Okay. So you have one more way. I think what happens there, they have given in steps actually that same thing. So you're seeing anaerobic reactors here, and they are passing few of the things as a return sludge from clarifier sedimentation tank. Okay. This is mainstream process, but with this some substream process also they will practice. You have already seen, no, uh, wait, I'll draw this. Yeah, with this they will practice upstream process also. There's some, you know, chemical way of adding, like coagulants they will add, lime and all, just like cement bags they will add lime. And because of that some more sludge will be collected, more of the organic can be removed, and phosphorus also we can remove, means with this, along with this they will do this also. Okay. So in the figure what you're seeing, one reactor is there, one tank, sedimentation tank they are kept here, and this only, with this they are passing this lime you're seeing, no, lime, it's a very good coagulant, it will make everything to settle, in all suspended particle they come closer and they will settle. Okay. So that is the thing. And then you have anaerobic stripper, means they will pass this liquid in an anaerobic condition. There also some phosphorus we can remove, and lime also they will, it will settle in the bottom. After we are passing lime, we have to remove the lime, excess lime also, right? You know it, right? After lime precipitation out, lime also we have to remove. So that is one process, anaerobic stripper. So the here lime is they are removing. Okay, so this is side stream process. Along with this, they do this also. It's just putting lime on coagulant. Okay, so these are the reactions. What happens? They are given uh, calcium phosphate hydroxyl ion. It will becomes hydroxy palite. This all is difficult to understand. Just you write on this flow chart, and if you practice this is good. This only reaction, this one you have to practice, because when we add lime, actually they're telling about this. This and all no reacting equation comes, but you are adding lime right here. Here, so that reaction they are explaining here. What happens? Okay, so this you practice slightly. Okay, so what else we have? Yeah, after that, when this flock forms, flock, you added lime, right? Or you can add aluminum sulfate also, alum. So if you add that, this reaction will take place. Any one you can add, and because of this, all thing will settle out. All aluminum, the phosphate becomes aluminum phosphate. Means it will become like a solid matter, phosphate thing, and it will settle in the bottom. Here also you're seeing. Okay, so it's settling in the bottom of the tank. This is a precipitated thing which is settled. If you add alum as a flocculant, here they added lime. If you add lime, this reaction will take place. And this hydroxypeptide means the phosphate which removed by forming a complex thing, hydroxypeptide. So it will settle in the bottom. Okay. So these are explanation of this side process. What happening here? What all the reaction happening here? Okay. So what else you have? Yeah. So few more topics you have. I'll try to zoom it. It is called advanced oxidation method. Advanced oxidation process. This is very new technology they are adapting, because if you see syllabus, actually when you see the syllabus after phosphorus removal, you have this topic. It is called advanced oxidation process. Okay, so this is like emerging technology. uh, they have given you to study, because it's completely new syllabus for you. What is this? You already know UV rays, ozone. Uh, so those things you have already heard. I mean, few things you know about that. UV is very disinfecting. When you buy a high end water purifier for your house, you will see UV rays passing every 4 hours there. So disinfecting happening. Okay, this model is all about tertiary treatment. Means you already treated the wastewater, then you want to treat it in a higher degree, like to attain drinking water standards, like that. So this whole removal of phosphorus, nitrogen is all tertiary treatment we call. It's a higher degree of treatment. So there you have one more topic called advanced oxidation process. So just inducing this oxidation state, everywhere we have seen how oxygen is one of the very important parameter he exists here. When we have to convert some impurity into his new higher oxidized state, and adding some chemicals, you used to precipitate out in the tank, and it is just like sludge. All impurity will be removed. It might be phosphorus, it might be nitrates. So that is the techniques you have seen. So that how you will enhance it, because treatment plant require more time, right? So here one more way of learning that advanced oxidation process. So I'll read this. What is that? Nowadays, organic waste are more difficult to be degraded by your biological process or membrane filtration. Okay, and uh, they will remove it in a very small concentration. Okay, the end product you will see like this compound dioxin, furane, or atrazine. These are all the end products you will see. Uh, okay, so now, but today's era 2020 we have a lot of advancements gone. So they are using these things UV rays and ozone synergenic sanitation we call. So this combination only we call as a advanced oxidation process. So what is here, what they are using here is there is an invention of a liquid waste treatment technology which utilizes oxidation method using ozone gas. So everywhere you have seen we are providing oxygen by in an aeration tank, right? We used to see some tank like this, right? So here we used to provide air, right? Everywhere we used to provide air by installing some pipes and all in a diffuse form, like, just like your fish. You will see now one bubble will be coming, motor air. So like that, this is very high air we used to pass, like 1 pascal pressure of air we used to diffuse by cylinder. So that is why you used to see all microbiological process. But this one is a very outdated process they're calling. It's because these technologies came now, this ozone and UV. So what it does is this what happening here is same oxidation process, right? So, but we can enhance this level by inducing ozone or UV rays. Okay, so that is the method ozone gas we can pass, and with that we can combine ultraviolet light also. What ultraviolet light do? It's very disinfecting. Your coronavirus can be removed by just passing this UV light, right? So this is a end technology, passing UV light, and here with ozone we are already doing oxidation, enhanced oxidation, and passing UV rays we are attaining disinfection, right? So that is why this method is innovation thing now we are using. Okay, so yes, so we will try to just we have to list on what are the technologies are available in now, because I don't know what question they will ask on this. So we'll clear this. I'll try to see what exists. Okay. So in the next topic, so then what are all principle adapted? So, so you got to know this thing oxidation we are enhancing by ozone, and for disinfection we are using UV light. So combination of these two things we call advanced oxidation system. So you're seeing this, what happens here, these reactions and all. I will send you this PDF. I have a PDF. These reactions are very good there. Uh, so it involves two stages of oxidation: the formation of strong oxidants like hydroxyl radicals, and reaction of this oxidant with organic contaminants in water. So these oxidant hydroxyl radicals, they start forming because of the ozone, you know, introducing that ozone to wastewater. So these radicals again try to react with contaminants in the water. Okay, so this is a two principle that happens. Okay, so what are all the methods are already there, and what is the emerging technology? So they have grouped into two here. We have hydrogen peroxide or ozone. Next you have wait a minute, okay. Okay, so see here. So what else? You have hydrogen peroxide, ozone or UV radiation you have, and both combination of these two things. You have one more hydrogen peroxide and UV. Okay, so these three methods you have. We are already using these methods, but so few more methods already emerging in the next era. We might use that. So those things are high energy electron beam irradiation or E beams we call. So this is in development phase. And one more phase we have cavitation or sonication or hydrodynamics method. So it is still in the process. They are still inventing this. So yeah, one more we had TiO2 catalyzed UV oxidation. So this is also emerging technologies, and Fenton reaction we have. So these all still they're not in practice. They're still in advancement. But these are we are already using. Okay. So you have to explain all these things. This PDF I will send you what all reaction happens. These are very easy. What happens with ozone and UV and this technology that we are adapting. These two things you have to explain if you face any question on this AOPs. Okay. So what else exists outside to see this? Okay. Okay. Then I think same. So this is how it looks. Technology. Pattern reaction. This you don't have to study all these things. Just mention these words and all. Cavitation, how it looks, because still and this is used in use actually. Hydrogen peroxide URS. This is in use because they have to generate this UV light, right? So this is all some technology they are adapting. With that, they are generating UV rays, and this hydrogen peroxide means your ozone, which forms radicals. That is hydrogen peroxide. So those things they are forming here, and they will put this into wastewater. Okay, so that is how the conversion happens. So just remember these terms and try to list down. Okay, so that's more than enough, I think. Yeah. So implementation, this advanced oxidation process still have not been put into commercial use. So we have not seen these all implementation in any of the thing in India actually, because especially in developing countries we are not seeing this technology because it's very costly, relatively high cost. There are roughly only 500 commercialized AOPs installation around the world at present. Means throughout the world you are seeing only 500. Okay, like in Europe, US, and in China, they are using these technology to treat the wastewater. But in India, we are not using this. It's very costly, relatively very costly. This one, but very rapid actually, very rapid. We can, filter the wastewater. Okay. So these are PDF I have. You can refer this. Okay. So this is what happens in AOP, advanced oxidation process. Okay. So these reactions, you have to, yeah, this one you learn, and this is all methods we have. Okay. So yeah, this is the one reaction which was missing, and that O conversation you can write down. Okay. So one or two reaction you remember. This not everything. This one you remember, and this reaction. Okay, two reaction, and this is all the methodology we have. Technologies. This electron beam I told, gamma rays you have, like that photochemical redox process. Means we are not using all this thing. They already told you only 500. We have commercial practice all around the world. In developing countries, it's not in use. Okay, so up to this today's class, we have 5 minutes left. Okay, so anyway, I recorded this video. I will send you. Okay, then any questions you can ask. Okay, then you have one more class. I think I will try to end the session. 11:30, I have one more class. Okay, I will end the session. Is it okay? No one is talking. Hello? Neha, Janikiram, Sachin.
Yes, sir. Yes, sir.
Okay, Sachin Gowda is there. Are you there? Sachin
Yes, sir.
is not listening, I think. Oh, you're there. Okay, Neha, are you there?
Yes, sir.
Okay, Sanjana,
Yes,
are you
sir.
following?
Yes, sir.
Okay, good, good. Okay, I have recorded. Fortunately, this like I will send you in. Okay, if you during internal you can refer this what to study because a lot of things are there. You have to study very few things. This is a very new topic for you for your syllabus. Fifth unit is very new. So please refer this video also. I will send you this video I have recorded. If you have any doubts, we will discuss. Just let me know if you have any doubts. Okay, I will end the session.